Okay, so we're looking at example 4 here, and it says find the solution to the given system of equations by graphing, and then we're told to check our answer to make sure that it is indeed the solution to the system. To do this, our first step is to graph both equations, and notice that the first equation is not in slope-intercept form, so we're going to rewrite this equation. So we take that x plus y equal to 0. Our goal is to isolate y, so we subtract x from both sides. And when we do that, we're left with y equals negative x plus 0. From here, we can say that our b value is 0 and that our slope is negative 1. And we should write our slope as a fraction, so we'll write it as negative 1 over 1. This means that we will move down 1 and 1 to the right. Or if you don't have room to move down and to the right, you can say move up 1, then 1 unit left. So let's begin by plotting that y-intercept. We go to where y is 0, put a point, and now we'll use the first definition, down 1 and right 1 unit. So from here, if we go down 1 and right 1, and we repeat this, we get a series of points. We can also use the second definition where we move up 1 and left 1. So I'll go back to the origin where I put my y-intercept, and I'll move up 1 and to the left 1. And this gives me a series of points through the coordinate plane so that I can have a more precise graph. When you're solving by the graphing method, you would like your drawings to be as precise as possible so that we can get a good result for the point of intersection. And now we'll graph the other equation, and we see that this is already in slope-intercept form. So we have a b value of 1 and a slope of negative 1/2. This slope of negative 1/2 means we will move down 1 and 2 to the right. Or you can move up 1, then 2 units left. So let's start at our y-intercept, go to the y-axis and put a point at 1. And we'll start with the first definition, move down 1 and 2 to the right. And we'll repeat this, down 1, 2 to the right, down 1, 2 to the right, to get a series of points. We see that we're getting further and further away from the line, so we're not going to intersect it out on this end. I'm going to go back to my y-intercept and reverse my slope to go up 1 and 2 units to the left. And this should help me find where it intersects the line. So from my y-intercept, I go up 1, 2 units to the left. I already found my intersection point. I hit the other line. I'm just going to generate a couple of more points so that my graph will be precise. I'll bring my straight edge back in here, line it up with my points. And now I will circle the point of intersection, and the coordinates there are -2, +2. So now we need to check this answer. I'm going to plug -2, +2 into the system. Anywhere there is an x, I'll plug -2. Anywhere there is a y, I will plug +2. We see that this first equation becomes -2 plus +2 equals 0. This is true. And here, the y is going to be +2 equals -1/2, and then the x, we plug in -2 plus 1. A negative times a negative is a positive, and 1/2 times 2 is 1. So we see that 1 plus 1 is equal to 2. Both equations are true. Therefore, negative 2, 2 is a solution to the system.